So this is lesson 2. We're working on representing functions and relations today. Last class we looked at relationships between two variables and how we might represent that on a graph. And today we're going to be looking at some other ways to represent relationships. In math, when we relate one variable to another, we call that a relation. I'm going to highlight that keyword here. And then we have some names for the sets of elements that we're relating to each other. So the first set of elements, we call that the domain. I'm going to be we'll use blue for domain today. So here we have vehicles being related to the number of wheels they each have. So the vehicles, tricycle, motorcycle, bicycle, and car, are all elements in the domain. And the number of wheels, these are the outputs, and they are all elements in what we call the range. Okay, this is also a function. So when each element in the domain in that first set has only one association in the range, then we call that a function. There's lots of ways to represent these functions. So this is one example. This is called an arrow diagram. I'm going to write these down. We can also use a graph like we did in lesson 1. We can use a table, and we're going to be seeing some of these representations below. We can use ordered pairs. By ordered pairs, I mean writing the points x, y. And then we can use words, we can use equations. There's lots of ways to represent relationships. I'll just write equations here, but we can also describe the relationship in words too. Okay, so let's look at some examples. Here we have an arrow diagram, and we have a set of elements in the domain on the left, 1, 4, and 9. And each of these is associated with one or more elements on the right. We have -3, -2, -1, 1, and 2. And the relationship is we're squaring. It's the square of. So first question is determine whether this relation is a function or not. So this is not a function. The reason this is not is because whenever you have an element in the domain being associated with more than one elements in the range, see how 1 has 2 associations here? It's associated with -1 and with +1. This makes the relationship unpredictable. If I give you an input, there's no clear output. And so we don't call that a function. I'm going to write that down here. Not a function because 1 and 4 in the domain are associated with 2 elements in the range. Okay, let's work on how we write down or describe what the domain and range is in any relationship. So the domain is the set of input values. It's the independent, the elements that are part of the independent variable. And the way that we make a list in math is we use braces. I sometimes call them curly brackets. So they look like this. And then we just want to list the elements in that first set there. So 1, 4, and 9, and then close your brackets. So those are all the elements in the domain of this relationship. On a graph, those would go along the x-axis. Okay, so then we have the range elements. And I'm going to list them again. Usually when you're listing and there's numbers, it's best to list in numerical order. That way, it's just easier to read. So I've got 5 elements in the range there, and I've listed them out with the braces. We'll work on other ways of listing domain and range too later in the chapter when we have continuous data. But for now, we just list them out like this. Okay, let's look at a table and how we might represent a relation in a table, and then we'll look at a graph. So here's a table. On the left, we always have the input values or the domain. if it was on a graph, these would be the x values. And then on the right, we always have the y values, or the dependent variable. Okay, so is this relation a function? So here I can see that each marble is associated with only one mass. So for that reason, yes, this is a function. The independent variable is the name of the elements in that first set there, so number of marbles. And that's in that first set. I'm going to use the same colors, blue here. The independent variable is always going on the left when we make a table, and it's always going along the x-axis when we make a graph. The dependent variable we always put second in a table, and it's always going along the y-axis on a graph. And here, that's the mass of the marbles. Now, if there's a unit of measurement, we should write it. So here it says they're being measured in grams, so I'll put G for grams. Okay, for domain and range, slightly different. We're just describing exactly what elements are part of each set. So for the domain, again, I'm going to look at the blue numbers there, and I'm going to list them out. So 1, 2, 3, and 4, and you want to use those braces to complete your list. And for the range, I'm looking at the numbers on the right, 1.27, and just listing them out. 2.54, 3.81, and 5.08. Okay, let's look at a graph now and how we might represent a relation that way and describe it. So here we have a graph of comparing ages of students and their shoe size. And there's a title here at the top that says student age and shoe size. So it says, for the relation represented by the graph, is this a function? And so what we have to remember is the input values, or the independent variable, is on the bottom here. And the output values are along this side here, along the y-axis. Now, if I look at, for example, students of age 6, I'm just going to zoom in there and look at what's happening with age 6. Now, I have two different points looking at students of age 6. I'm going to write their coordinates down. I have one student of age 6. He has a shoe size, or she has a shoe size of 1. And then I have another student of age 6, and they have a shoe size of 1.5. So this is not a function, because whenever you have an input value that's associated with more than one output, so an x value that has more than one y value associated with it, it's not a function. So no, because there, oops, put an extra s there, because there are x values that are associated with more than one y value. I encourage you to have a look at this graph and see if you can see another age that kind of means that this is not a function. So is there another age there that has multiple different shoe sizes associated with it? I'll give you a second to think. Yeah, so the other age that has more than one shoe size associated with it is age 10. If we look here, there are two shoe sizes associated with age 10 students. We have 3.5 and a shoe size of 5. So again, this means that this is not a function, because to be a function, each input, each x value, can only be associated with one y value. Sometimes people call this the vertical line test. If you can draw a vertical line on your graph and it hits 2 points or more, then it's not a function, because this would mean that that x value has more than one y value associated with it. So if you want to write that down, you can. It's called the vertical line test. It's a nice visual way to tell if a graph is a function or not. Okay, so again, if you draw a vertical line and it hits more than 1 point, it's not a function. Okay, the independent variable, maybe pause the video here, see if you can identify these, and then I'll write these in. Okay, age of the student is along our x-axis there. I'm going to use the same coloring. Dependent variable, that's the description along the y-axis, shoe size and US shoe sizes. So you should always include the unit if you're talking about if you have something that has a measurement. And then domain and range, we're actually listing the points. I'm going to get rid of some of my markings here on the graph so we can do a better job of that. Okay, so for domain, I'm going to do these on 2 separate lines here. I'm going to list all the x values that have a point associated with them. So these first, I'm going to go left to right as well, just so I can go in numerical order. These first 2 points, they have a x value of 6. So I'm going to put 6 on my list for domain. Then next I see here, this point has a age of student being 7. So I'm going to put 7 on my list. Then I have a shoe size here at 8. Then one at 9. Then 2 at 10, like we talked about before. You don't have to write 10 twice. You're just writing all the x values that are on the graph, that we see somewhere on the graph. And then we don't have any for 11, but we do have here one at age 12. So those are all the ages that I see on this graph. That's why I've put all these numbers on my list. And I use those curly braces to complete my list. Then for the range, I'm going to erase some of these markings. For the range, I'm looking at the y values and which ones are part of my graph. So I'm going to go from bottom to top just so I can go numerical order. So the first one here I see is shoe size of 1. Then I have here a shoe size of 1.5. And then I have a shoe size here of 2.5, halfway between 2 and 3. And I'll just list the rest here. 3, 4, and then I have 5, and finally 6. Those are all the shoe sizes that are represented on the graph. So that's how we write the domain. There we go. Okay, and that's the end of the lesson.